and small n that's a natural number, such that we have the sequence an minus a, which is the limit, to be smaller than epsilon. So now I don't think I could give you guys the sequences. I'm really struggling to do this, but so
maybe try start from some sequence that you know, then try very.
I can only think of one divided by n. That's all.
You should try first. You should try the easiest one first.
Okay.
I mean, you should even try with the constant sequence.
Anyway, so let's just take that previously mentioned 1 divided by n as an example. So we have epsilon is greater than 0. So we just do like something like an epsilon square or something. We have this. Then over here is a, that's our limit. We have this line here. So these are the epsilons, which is the distance of an minus a. Could be kind of e. Doesn't matter that much, hopefully. So there exists natural numbers n to satisfy this condition. So we could just put like so something like this could work because it fits basically any natural number with I mean, if it fits from all, then it should fit for some. So if we put like maybe anything behind can work, then by that logic, the same thing over here, which works for everything here. So we could have a sequence where it's just gonna be 1 divided by n plus a depending on this part. And then if it would be on 0, then it would be like 1 divided by n. But since we're putting it on a, then it could put something like this. The same could probably put for this. How am I supposed to do? I don't know how I'm gonna write this one. Probably figure. So this is what I get from sub question A. As for sub question B,
oh, so you solved it already?
Yeah, this is just one of them.
Okay. I'm very okay.
So for sub question B, there's a bit of a different term. This part still applies, and so does this, but now they have a additional condition for some. Is it? Oh, no, this one's different. This is a capital N. This is a small n bigger than the capital N. This is the new condition, such that it still fits this thing that we wanted before. So as for this one, this is where things get somewhat a slightly bit different. It's probably not too much different as compared to this one. The same thing still applies. We still have that epsilon limit over here. A epsilon limit. And the only thing that's different now is that we have an capital N over here. So anything behind here that's n greater than n would converge to L, I mean, or A limit. Anything beyond this part, it wouldn't work. This is for some specific AN. So it doesn't mean it needs to be constructed for all kinds of natural numbers, small n over n. So something like here. I'm thinking something like this. This is probably like the tangent. It could work. I don't know. I'm just like saying. I don't even know.
No, you can't have tangent sequence, right? You can have sequence like going to infinity somewhere and then
Yeah, but the
I mean like how do you write down the sequence? You write down a sequence.
Tangent one, tangent two.
tangent one. Yeah, maybe.
Tangent one, tangent two. Oh, okay. In that case,
It's just that these parts would fit the condition of a sum because it doesn't say it needs to be all of them. I'm just taking the sum part of it. So these parts still kind of count. It's just that these ones don't. So I mean, there's probably a better way to use it, and it'll probably just be this again, but like
okay.
the condition is to try not to repeat this thing over again. So I'm just like really trying to think of anything else that's different.
Okay, I think good. I think that's good. I think we run out of time. Okay, then good. I think that's good.
Thank you.
Okay, so yeah, good. I didn't know that your English is so good.
Okay, like,
Where did you learn your English?
school.
Which school? Government school.
No, private.
I see.
Private.
You're from international school or what?
读中.
Duzhong.
Yeah.
Duzhong. Wow. Impressive. Eh? Your Duzhong is speak English one.
中有啦
Where is it?
English
Where is it?
English week
哪里可能那英语有用？
你就可以讲说，哦哟，这个星期你就要去
来，哪一个读中？昆城啊，没有啊，我遇到昆城不一定像你这样好英文，确实有好英文的，都说啊，但是也有来系列，这个系列。反正我有遇到昆城英文的这样。
他讲读中
Okay, but anyways, right, good. But then actually you realize here this is a convergent sequence, right? So convergent sequence have this, right? For all epsilon greater than 0, there's this n in n. So okay, not this time. There is a capital N in n such that for all n greater. Okay, so if you realize that this is our limit, see the definition, right? But if you see what's the question asking about is like, I'm trying to remove some of the quantifier, or I change the for all to the as. So I'm trying to lead you to think that if my sequence is not convergent, can I have different kind of these various way of description of not convergent sequence? Okay, but some description using epsilon. Okay, so for example, in this case, what I've done is I actually, what did I do? I remove this part here. I don't look at the tail end. I look at every single term. Every single term? No, just as if sum n is in there. Okay. So maybe you can think of one example is, if it doesn't converge, does it satisfy the condition A? Yeah, you have examples. But identity converge, right? What do you mean by identity? Oh, you mean the huh?
AN equals N.
AN equals N. Does this work?
And then choose A was some natural number.
Oh. This doesn't work, right? But if your epsilon is like 0, I mean, it doesn't work when your epsilon is 1, right? Right. If your epsilon is 1, oh, what's your A? What's your A first?
Some natural number. A equals N, whatever N is.
But it won't work, right? Because if you pick some N here, and then yeah, your epsilon is 1, then
this thing is always in the, it's always epsilon within epsilon of this thing. Or 那个是 M， 那个不是 A。
AN is N, right?
Yeah.
AN is N. And then let's say we pick A to be 2, right?
Yeah.
Let's say
I think that's valid.
this valid. Let me think.
就是
哦
不管什么 epsilon，
Oh, okay, okay. So this itself is oh, okay, okay. So this A2 is okay, yeah, sure. Okay. Does everyone see this example? So let's say he take AN to be n, and then take A to be 2, let's say. Any number will work. So for every epsilon, there will be someone that is epsilon close to 2, which is this point A2. Okay, yeah.
这样子的话，这个不是可以不for every sequence 来？如果这样子，如果用这个 trick，
没有错，没有错。没有错，没有错。But then you have to pick your A nicely, right? If you pick this A, if you pick this different A, then it doesn't work. You do know which A doesn't work?
就是在两个点之间。
Yeah, as long as not on the sequence, it's not the sequence, then it doesn't work.
我以为这个 A 是 every A。
啊，对， then 那个又是另外一个 story 了。只要是3，我们这个只是因为 limit convert 你不是 convert 去 every A， 对不对？
A 哦，
对不对 ？So 我们还是选一个它 make sense 的地方。
OK。
Yeah. Okay. Right. 对，没有错。Okay. Why just now I comment on this picture? Why I don't like this picture is because when we draw tangent, right, we draw like this, right? We really mean the curve going to infinity, and you will take all the value up there. But you need to remember, your sequence is discrete. So it will be bounded actually. So you will stop somewhere, depending on what number you substitute in. And it will stop somewhere. Okay, so this picture, there's some misleading part, unless you stop it somewhere. So then that will make more sense. Okay. But 这个 example 问吗？What A you pick? Any also any point on your sequence? Oh, then you just like wait, let me think. But this one need to be strictly because it's periodic, so it will get repeated.
Oh,
yeah. Because this one need to be work for some n that's greater than. Oh, might not be repeated, right? Oh, might not, because it repeat on the unless you make it like tangent of you need to put in the shape.
X over 2 pi something like that.
S over 2 pi.
Over 2 pi times 2 pi x.
2 pi x is
Something
enough.
like that. Or pi x. Pi x.
Pi. So you need to try and make it repeat. Try to make it repeat. Otherwise, if you just use real number, right, it might like jump. But then you need to make it a periodic one so that you will pick this constant stuff. Like, you get what I said? Maybe, don't know. How do I say it?
Plus x 是吗？还是 2 pi x 半？
Maybe I should draw it actually. Let me draw it. Should we talk about tangent or maybe sine also can? So for example, if you look at these points, right? So what are these points actually? So first one is pi over 2. The other one is 2 pi, right? So this one is 5 pi.
是 2 pi 吧？是那个3 pi 或3 pi？
一个
是那个在中间那个点。
Oh, sorry. Oh, okay, sorry. For sure. 应该是 this one is 2 pi. Yeah. Okay, and then this one is 5 pi
over 2.
Okay. So what do you see? Do you see the period here? So how do you go from here to here actually? You plus 2 pi, right?
Yeah.
Because your period is 2 pi. So actually it's pi over 2 plus 2 pi. So so how do you make this a sequence? So the next one, how about the next one? So the next one is, I think you just plus a 2 pi, right? So what do you get? 7? No, 7, right? It's 9 pi over 2. Right? Okay, so meaning what? So you add a multiple of 2 pi here. So you are picking this one. So in this case here, if you want to like picking the same value on this tangent, you also need to do the same. So what's the period here? Also 2 pi, right?
No, technically it's pi.
Huh?
Technically it's period of pi.
Tangent is pi. Let me think.
Yeah.
So here is pi over 2. Oh, yeah, right. So pi over 2 here is negative pi over 2. So it's just. Okay, so you need to plus n pi.
Yeah.
N pi, but then n pi is boring. Is it boring? N pi is boring, right? Because
Maybe I think just as long as there is a pi, there is a period.
maybe you can add
a
a
constant,
+1, right? But then it's also boring.
As long as there is a pi here, maybe pi over 2, pi over 3 is period.
No, I mean this function is boring, right?
Yeah.
Because it's just a constant.
I mean, if you maybe you change the n pi into maybe n pi over 2 or something, whatever, make it interesting.
Make it interesting.
Yeah.
I mean, like the point here is like we want to make sure that this will hold, right? But then we are not sure that if it hold for 1a here, like let's say hit a equals to a1, let's say, but does it hold for the an where n greater than 1? I don't know. But then if you can pick this period of points into it, then you will make sure that the same point will occur again. This is my idea, but then not sure how to write this down yet. Maybe you can try. If you want to continue with this, you can try think about it. You should try and think about it. Yeah. Okay. Yeah. So I mean, like one thing about the pure maths course is everyone think differently, but everyone can pursue differently. Actually, 明白讲吗？ This is the main reason why I don't want to teach standard solution. You understand? Because if I teach standard solution, everyone will just gonna write that one. But you see, whatever you draw here is different from what he draw or what my solution draws, actually. So all these will work as long as you're answering the question. Okay, so you should learn to extend your own idea. OK 吗？所以你真的认真可以去想一下，你这个 tangent 这样写出来。I mean 你写下那几个啊，比如像刚才我们这样子做啊，写下那几个啊，很有可能是错的。那你可以从这边开始调，它是可以调啊，它不是说错就是错了啊，错是可以调的，它可以调到对为止。OK 吗？呀，我觉得你可以 try 一下。而且这种东西是很 personal 的，你叫他 try 啊，你不一定能 try 得到的。所以你要 try 你自己的东西，就是有自己的想法，这样子，这样。OK。Next people， 来，金汉。差不多最后5分钟了。来，擦掉。来，这个帮他擦一下。有 T 恤吗？你的口袋真的是很那个显眼的。
这么神奇啊！
First, we can do some revision of the game. Do some revision of this one. So we first define the so okay, this can be defined for every bounded sequence, because by the horizontal theorem, every bounded sequence has a convergence subsequence. So when an is bounded, we can try to find.
If an is bounded, you can try and write down, suppose an is bounded first. Yeah, instead of just mention. Yeah, you can start with an is bounded first.
So we know by the definition of Bn is really Bn is due to the monotone convergence theorem. We have Bn converges to some reasonable problem. So we define limit of Bn as the upper of the also by the monotonic confidence theorem. This is okay. Let's see the question.
So you can sign in your attendance. Yeah, almost forgot.
Since since this is the influence of Bn, so by the by definition of influence, there are infinitely many positive integer n such that is influence less than Bn. This should so okay, so this gives us two cases. So it's easy to think that if the supremum of an always updated, that is, if we and as n goes to infinity, Bn always decreasing. So in this case, we can just let uh, so if Bn always decreasing, this means that we always have to find a new supremum of AK to the rest of the for n for the this set. So we can always have different AK such that AK equals to Bn. But this is the case one.
Okay, maybe I think we should stop.
Oh,
Yeah, we don't have time for you to.
then
Uh,
what can I
Can you what? You what? What do you want to do?
就我能
啊，这样
就
你要咋了？
可是那我这个就这样了。
啊，因为我们时间到了，不好意思。啊，什么？对，看一下答案啊。我答案之后会 pause，but then 我可以 comment 一下，不用插，不用插电，先不要插电，先不要插电。呀，等一下再插。So hello，可以进来，这是可以进来。So this question actually slightly long, not very long, but then you need to understand what it says. So basically, this this question is giving you a equivalent definition for leaf soup. Okay, as equivalent, is it equivalent? Or this is a consequence of the leaf soup. Okay. So what's this question testing you is actually is to understand this part here, I guess. Increment of what's your BN? Okay. So it's the understanding of this part actually. Increment of this soup of it. Okay, great. Okay. Yeah. So he realized that in the end. He realized it in the end. Yeah. But then yeah, so this two part here is wrong. Okay. So you need to rely on this to build it. Okay. Yeah. 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 So one very important definition you need to use in this question is the soup definition. Soup definition using epsilon. Okay. That means for all epsilon greater than 0, there should exist something in your set such that soup or A is greater than soup A minus epsilon. Okay, so this is the main thing we keep using in this question. Okay, so you need to use this somehow to help you to build this infinitely many positive term. Okay, you need to use this because you can see that there's a lot of soup here. Okay, so use this soup to build a lot of A for you. Okay, yeah. Can you get the idea? I will post the solution later, but then try to get the idea first so that when you read the solution, you know what's going on. And then there's another part, right? There exists a positive integer n. If small n greater than n, then a n less than l plus epsilon. This one could be easier, actually. This one should be easier. By the definition of L. Yeah, this is the limit part. But then the harder part is the infinitely many positive integer. That one is to use this soup for infinitely many times. You see, this soup work for infinitely many k, right? Yeah, because you take your n to infinity. So there's an infinite part from here. Okay, infinite part from here. And then the last part is the limit part. Is this a limit? Or the in part? Okay, yeah, these two parts will give you the two things inside the question. Okay, yeah. So maybe we have less time, but this question is also very challenging. So maybe you need to try to learn how to present a hard question in a short time. Yeah. Okay. You cannot like waste too many time. No time for you to think actually. So what does this mean? So this means that you need to be more familiar with your content that you present. Yeah. If you stuck, then you go up present also stuck. Okay, so you need to be more familiar. Okay, yeah. Did you heard about 3-minute thesis presentation or competition actually? 3 minutes. Okay. So usually university will organize a competition for like postgrad, master, or PhD. They only use 3 minutes to talk about their thesis. You know, thesis is how long? Usually it's like 100 pages. Not the pages only. It's about the content. The content could be very hard, very professional, or what we should say, or very new even in that profession. Okay, so how do you explain this hard concept, hard stuff, hard content, 3 minutes to audience? Okay, very challenging. Okay, so they make it a trend now. I think SMUM is starting this trend. I think at least last year they have it, or 2 years ago. They start to have it for the master, 3 minutes thesis presentation. Yeah, how do you make sense of your stuff in 3 minutes? For someone that's don't know one, zero, don't know about the thing. Okay. It's very challenging and it's very cool stuff too. Okay, any question so far? Okay, yeah. So these 2 parts here will give you the what question, but then you need to write down what it means so that you can get what you want. Okay, so far, okay. Okay. If no problem, we will upload the solution later. Did you guys read my solution or not for previous tutorial? Did you read? 有吗？有读吗？没有就没有，有就有。哦，没有 ，OK， 没有不要紧。But then 会读吗？会吗？考试前会看吗？啊，这样越早看越好啊，不要等下到最后一天你那边很紧张哦，大家看不懂哦。Okay, so if you read, you don't understand, or you found problem mistake, you should let me know. Okay, you should let me know. Yeah, I think there are some typo, but I fixed some of them already. But then, yeah, you should let me know. Okay, good. 还有问题吗？考试考什么？有问题吗？啊，考试考什么？OK，我们下个星期再讲。我决定了。
要考试啊。
I mean 考什么我已经跟你们讲了，只是说来多 specific， 我们之后再讲。Yeah. 什么？啊？什么？还有什么 ？Yeah. OK， 谢谢，拜拜，拜拜，Group One。啊？
会考我学过的字。
你很适合做老师。
通常多老师会有这种想法，就是你们。我们就算知道我是不是。
OK。Yes。
刚刚没有签到，然后
没有签到
时间过啊，所以我才签不进去。
好，我会帮你签过。
谢谢。
好，没问题。这样的话，我们现在赶紧签 ，Group Two 可以签了，赶紧签，赶紧签到，不要忘记去。拜拜，拜拜。啊？剪刀送福利是什么意思？
剪刀送福利。
哦。前一天、前2天、前7天有送礼大礼包，送你大礼包。
连续签到7天可以送你大礼包。
真的送你大礼包。哪些？这个part 就很重要。这个 part 其实是因为我们在班上 propose 这个 non-increasing
啊，对啊，是吧？
然后它，有没有 assume bounded 我们的 definition？
有吧？
有没？
有吧？
我们 definition 有没？
没有啊。
definition 有没？这个是这题才 bounded 还是？这 bounded 是哪里来的？这个题目来的。
这是什么题目啊？
这是这个题目bounded，你乱讲了。哦，原来你是乱讲的。I see，原来你乱讲，这样
这是什么题目？
这样乱讲。
就是乱讲。
他乱讲了，他乱加的，不是乱讲啦，乱讲。
这个不 define
这个 bounded
为什么是？因为 BBN 是那个是 decreasing 还是 decreasing？ 那肯定啊，它不是。
哦 ，OK。
哦，OK。
这个。
No，I should say， bounded 你乱加的，原来如此，不可以这样乱加，不可以乱加，不可以乱加。OK， 我是告诉你不可以乱加。OK， 这个东西是它 limit exists， 它是 assume 它 exists 过后，这个
是讨论程式。
没有我们讨论数学。
你是不是要不要先让大家知道？
哦，对，哎，等一下不要扰乱我，我们要先上课先，等一下我再回答你们问题。OK，so we should start a new session now. OK，so 差一点忘记了，时间很紧迫。
而且我们说我们10分钟说40分钟。
So right. Okay, so today we will do question 5 and 7 Okay, so who haven't presented? 所以你还有呢？就你吧，你两个，就你两个吧，两个吧。OK， 好，我给你们选择5、6、7，你们要选哪个？你要6 ，OK， 好。那个呢？浩然呢？先选一个，没有办法，我们训练你做出来，因为这些都是有答案的，其实。你就直觉哪一个你想要？5、6、7，六被选了。7哈 ，OK， 很好，非常好，答我完。OK，then in that case，我们就 break into groups 啊。OK， 你们一人带一组啊。呀，你们带了一人带一组，可以讨论。OK， 5、6跟7 ，OK。好。呀，这个是因为它是 non decreasing， 所以 non increasing，non increasing，
它是往下，
它是往下。所以如果 limit exist 的话，你可以 prove 它一定要是 in， 它有一点 monotone convergence theorem 的 proof。
这个理解。
然后你要问什么？你不是问这个？
是
啊，他没有保证，也是他自己加的。哎，这个条件不可以自己乱加哦。
所以题
这保证，
这个没有保
啊。你如果解包的又解安包，那这样就很多事情啊。其实这个东西不一定保的，不一定，它可以无限下去了。只是说如果这个号码 exist 的话，它应该是它的 infimum， 明白什么意思吗？啊，请说。哦 ，improve 哦，你
那肯定是有，肯定有sequence。subsequence， 那这 subsequence 肯定有大于小于水平，然后就到这个。
可是你这样讨论，它就不 general 哦。你可能只是可以说是哦，从这个情况我们可以看到这句话是对的，但是你还是还没有学到这句。对，感觉你要上完我的课。
应该聊啥？
没有啦，就是他刚才加了一个额外条件进去，好不好的？
里面说可以。
呀，什么？直接做吧，你直接去把这个的 definition 挖出来，它就会出来啊，这个东西。它就会出来啊。
所以 B
闭嘴了 ，OK， 好，拜拜。
所以
下次再见。
所以 B 这个sequence是什么
啊
？B 是什么 sequence？
？B 是那个 sequence， 那 define 的。是。
哦，看到。哦。
越来越好。
OK， 哎，思慧，这么你一个人？来跟他一起，来一起讨论，不要误会，不要误会。之后想在一起，我也会阻止。
你能不能先解决你自己的人生大事，再去关心别人？
我在关心世界的。OK 吗？还有问题吗？
可是说 supreme 会跟
你还在想啊 ？OK 啊
，supreme 会跟 infimum 的关系。
？supreme 跟 infimum 没有，他要看这个东西的里面。
啊
？OK， 如果这个里面 exist 的话，应该是这个东西这个 set 的 infimum 来的，这个 claim。
所以现在A 这个 AN 它可能它是安包的，它可能是安包的，所以这样子的话，这个就不等于哦，
就不 exist， 连 limit
哦
都不 exist。不是，它不会安包的，它只会往下吧，它只会往它哪个地方？
好像这个，
对，
上下上，其实
对，
你看它的那个
那
个
算就一直下咯，它数就一直下咯。
如果上来无穷的话，一定是肯定逆行逆
它数就一直下。
可以一定是about increase
non increasing，
哦，
因为你可能会把高的丢掉嘛，你比较有可能性是把高，如果你没有把高的丢掉，它已经maintain在那边了，
小，
你只有可能是把高的丢掉，你才会掉下来。 如果你把低的丢掉，你的 supreme 一定是 maintain 在那边，所以你只会 maintain 或下 maintain 或下。make sense？
是因为
想看就是如果这个直接被存在的话，
这是什么？这是什么？
OK， 其实 you can go around， 你们可以走走看看一下。
就不是临时明
小月可以走走问他们，因为他们有时候很害羞。
等一下，我说你是 non increasing 吗？啊，是 non increasing，
non decreasing。
哦，那
no sorry，non increasing， 它才会下去。non increasing， 它没有上去，所以它会很多下去。
看如果好像这个到后面就一直
那个是基本上
最高对，但是你要记得哦，我们是给它擦掉了。我们是拿 A 大于 N， 是说对，我们就是反正应该是一样的。那个就是我们慢慢剔除前面几个。
剔除前面不是后面，
我肯定不是后面吗？后面讲题我因为讲
或者讲成另外一个，我是讲成
没有
A2 A3 慢慢加进去。
啊，不是这个概念
我，讲错，
这个概念跟 sequence 应该就是一样的吧？
因为我是想这个，
对我讲你慢慢加进去应该就是 sequence 啊。现在就是来
这是把后面剔掉，
把前面剔掉。
哦，从前面开始剔，
对。
它是让你取了数不大概
叫我
这个取。
把前面剔掉。
里面手 primo， 这是 infimo， 就是里面手 primo， 因为这里面有 limit primo， 而且它这边取了2次，先取了数不，再取了里面先取。但是 B 人看到没有？不是 A 里面手 primo， 里面手 primo。我把会给你看哪？哎 ，OK， 这是 infimo of supremo。A1 的你 A1 照片那个好像对 ，OK， 我看到了 infimo of infimo of supremo 啊。
这不就是零 definition？ 没让他们没什么事情做，没什么事情先跑，别让他们吃，你没有会注意到。
我只想搞完个题。
你可以回去看看答案。
是卡
有啊，第7题是绑的，有绑的，仔细看，也有绑的，第7题也有绑的。
只是说那个
写下来存在，你写下来
什么？它是有绑的，是有绑的。它的 definition 是没有绑的，因为我们 definition 是说，来，如果 make sense 我们才叫它零，通常我们写那个号码。
可以这么定义，
可以定义吧 ？maybe。
是，
所以 that's why 我们也没有很那个。
为什么它
influence
它 limit 出来是一个 sequence
啊？
它 limit 出来是一个 sequence。
limit 出来是一个 sequence， 不是
这个不是
in 或者 sub of 一个东西是一个号码吗？
是啊，可是为什么它这个表示不是一个
没有，是这个 super AK 是 BM， 然后再取了 limit 就是对它取 infinite。
我知道，所以它现在是一个可是它这样写不是被它这样写
in of 一个 set 吗？一个是一定是
可是它
号码。
你看这 n 大于
可以的呀。
它现在是一个它只是一个 number 吧？
他其实他想表达的是这个意思，但是我记得这么写是可以的。
哦，
我今天抄的是本书，这个就是这个。
不是，这你要表达。
但是我想问你，
可是这样子，哦，是
是一个意思呀。notation问题吧
notation 问题。
我只是想问你的是，为什么你要中间过一再一个在那？但不然这个是直接的有这个。
我们 define 这个啊，这个等于其实我没有说给你们看啊，反正可以被推出来了，从我教的东西，反正就要有一个过程。反正，yeah， 反正其实我在班上也只是提这个东西嘛，应该这个东西够用了的，这个东西应该够用。反正如果你要用这个也是可以的，但是你要有这个啦。反正我在班上没有 proof， 但是如果我跟你讲的话，就你可以用，但是你可以推出来，可以真说从我教的东西。infimum 可以 negative， 可以 infinity 吗 ？supreme infinity
是不是应该不是可以？
But then 如果我 define 这样的话，不是意思说 infimum 也可以那个？
为什么不能 infinity？if you supreme 我可以放 infinity 啊，negative infinity 就是说我们不需要它是一个 real number 啊。if you supreme 不一定是一个 real number 啊，所以你需要
这样不 make sense，因为
我们这是有 convention 的。
我想想，
比如说 supreme of e to power of x 它是 infinity。
那我觉得没毛病啊。
哦，
对啊，就我们有 infinity 和 negative infinity 的。
就是不存在
你们和或者可以放 supreme 和
定义吧。
大家有没有定义过这个？因为它不是 real number 的话，我们通常是，我印象我没有看到过
不可以，我们没有定义 real，我们没有定义，unless 我们要 by convention 把这个 infinity case 加进去。我们定义的limit， 定义的supremum。OK，all of them have to be real number。如果你有注意我看那个 define limit 的话，我会讲 limit 等于 infinity， 当它 diverge 的时候 ，yeah， 它不会符合那个 epsilon 的那个 limit 的那个 definition。
你可以额外
定义。OK，这个 infimum 是不会给你 infinity 或者 negative infinity。
所以这个是这个是什么啊？你跟他讲，
这个是什么？
就现在到这里了过后，然后你讲不可以等，不可以给，
对，不会 infinity，因为我们 define supremum or infimum 是一个 real number， 它是一个号码，我们不承认 infinity 这个 real number。
就是
OK，
因为是小的，对，小的。
OK， 品杰，你知道发生什么事情吗？哦，怎么你知道呢 ？Why you know？ 有人讲谁？坐过去跟我们一起。Yes。可以用，对，你可以用 infimum 的定义。
不是这个不是不同于我们那三个定义，它只是叫做 infinity。哦，就是这个。
人这个是 in 法，这个不是数吗？应该 in 法。你是说用 infimum 的那个 equivalent 定义哈？equivalent 定义 for infimum 应该是 for every f 的这个such that 到反加要不要到反？a 要这个是大，所以你要小in a 应该是加 epsilon 对吗？对，它加了它就进去了。OK， 这样对。对，你用这个，but then 这个是 in 反正，你这边要是 in， 还是这里是要 in。对，
这个只是一个 necessary condition。
actually 是 necessary and sufficient equivalent。
为什么？
你可以 prove。上次我们有 prove for 这个吗？这个我们 prove 过了，这个可以 if and only 这个，说这个也是类似。
这个就是 Simon One 的题。我的那个
Simon One，
我的 tutorial 就是 any open interval。
OK，
哦，类似，
就是
呀，类似。
你说这个是一表1 condition for supreme 的其实
哪个？这个？
你说这个
啊，对，这个会 imply OK，sorry 啊 ，maybe 你要 start with sub A， 你一定要 confirm 它是个 upper bound。Then with 这个
对，
这个，
所以我就奇怪了。
OK， 或者说这个是 equivalent to saying that 每一个小于 sub A 的东西都不是 is not 对，所以他才讲出 assignment 的那个东西，因为这个是 equivalent to 每一个小于它都不是一个 upper。反正这个东西是要另外有，你要知道这个东西是 upper bound 先，加了这个条件过后才是 least upper bound。你问我，你这个你要用这个，你要用这个，对。But then 这个不是 bn 哦，这个是 in bn。
就是 bn。
in bn 你要 in 吗？
不是，我是
这个是 in b。
因为 L 是
yes。
第二道词就额外定义。
对，要额外。
所以你这边是从头到尾不打算额外定义？
没有啊，我没有用到 infinity 的东西，我也不要 care 啊。
OK。
那你就不 follow convention。
不是我没有 follow，我只是没有 introduce convention，我没有讲我不要 follow，
行，
我没有 introduce 吧，因为我不想来，没有必要，没有用的，暂时没有。我们在这边想学那种 epsilon delta 的算法吧。
哦，
But then I mean like 你会了这些过后，你看这种 convention 应该是蛮简单的，我觉得。嗯。嗯哼。哦，OK 啊，then OK，then sure，yeah，sure，yeah，可以。
是要用这个下面就 proof。
不用 proof 吧，不用 proof 吧，帮上 proof，
行，
不用吧。所以这个答案其实没有很长，只是你要把这些定义写出来吧。它答案就会出来。
我的问题是哦，为什么会牵扯到 infinity 那个后面的部分？为什么会牵扯到？为什么会牵扯到？虽然讲你讲是错的嘛，这个后面这个部分infer 这个部分牵扯到 infinity， 为什么会牵扯到 infinity？
哦，没有啦，他们因为你刚才讲 non increasing 嘛，但是 non increasing 有一个情况是它一直下去嘛，then 它的 limit 就是会 diverge 啊。我们其实 define 那个 diverge 的情况叫做 limit 是 infinity。
negative infinity。
negative infinity。
不帮边的。
可是这个跟我们要
这个不会有这个事情发生，因为它 n 本身都 bounded 了，这个情况不会发生。他的意思是说，平时的话，你拿随便的 an 的话，这个东西不一定是一个
随便的 an，
对，
然后这个不会是，
就是这个 info exist 啊，这样子讲，或者我们课室来讲说，如果是 infinity， 我们会讲它的 info exist， 我们的 convention 啊，这个unless 你要拿那个 infinity 来做事情啊，反正我觉得你做不了什么事情。
然后从这里又到那个 infinitely many n， 这个
在说里面的 n 趋近于无穷的 x n 等于0。
那个我承认，你知道为什么吗？因为那种有不同的 diverse 方法，它可能不是永远上去的 diverse，反正这个如果你的话，你是问大小嘛，就是问那个 greater 说谁的包嘛。
可是那如果这样子的话，这个地方都不填的。
所以我们只 assume 那个 limit exist 的时候，我们才开始 proof。我们这个号码出现的时候，我才开始 proof 这个。这个 limit exist 的话，我才开始证明它的等于。
这个后面这个部分将牵扯到后面这个 infinitely many。
哦，这个其实你不用透过 in 也可以啊，你透过这个 limit 也可以。
因为什么？
这个 limit 会给你，这个 limit 会给你。没有什么，你讲吗？
为
by definition，
对，因为为什么？这样跟那个infinitely many and 又有什么关系？
因为
讲拍过去。
因为你要知道 limit 的 definition 是 work for all epsilon，每一个 epsilon 都会送你一个 n，所以你要玩这个 epsilon。
OK。
对，我刚说，你记得在我们班不是我有给你一个 decreasing 的 epsilon， 然后 create 一个 sequence that converge to A，那个，你要用那个 epsilon， 因为它 for all epsilon 大于0嘛，所以你的 epsilon 可以越来越小，那它就会给你新的那个 term， 可以 try 写下来。
然后我可以发现这个。然后接下来还就没写完哦。
没有写完。
OK。还是你写了再发给老师啊，再看。
对呀，
因为
没有你先写先，然后你再看一下我的答案，然后你看一下不 make sense， 然后不 make sense， 你可以再问。
我们要 present。
你 try 一下写下来，然后看一下哪里漏掉啊，还是少了什么啊，多了什么啊，这样。OK， 好，来，把它查一下。Cauchy 啊，看好，
不是 Cauchy，
Cauchy，
他不是叫红军的。
红军，他是红军。
对啊，他是红军。我讲一点。
有看过 Cauchy 的照片吗？
那个右旋有发在他那个
哦，是哎，哎，怎么你的那个有 laser 版本的？你自己加上去的？哦，够力了，我没有看过。
很不尊重数学。
你不尊重普丁，没有啊？
我也要尊重普京。
哎，没有，那个是他照片好像，那是他照片，是照片，
照片
不是。你如果你看到我 share 的有一本书啊，那本叫什么名啊？那个卡明的书，J 卡明的书，他有 compare Cauchy 跟那个普丁的照片，他长得很像普丁。
我们今天打了对吧？
OK，来，第二 floor。
他打了对吧？你再继续讲。
an minus an less than epsilon. Then we take epsilon greater than 0. Then by an and bn is quantification, we have axis and n1 and n2. And m and n greater than n1, an minus an less than epsilon, and n greater or equal to n2, bn minus bn less than epsilon. Then we have Cn minus Cn is equal to the absolute value of this. Then by the reverse triangle inequality, we have this thing is less than or equal to this an minus a, then an minus an minus am minus bn plus bn. And we can turn it into an minus am plus b, then wait, bn minus wait. Minus bn minus bm. Then by triangle inequality, this is less than or equal to an minus am plus bn minus bm. And we want to show that it is less than epsilon. We take this epsilon to be epsilon over 2. Then or equal to epsilon over 2 plus epsilon less than epsilon over 2 plus epsilon over 2. And it is equal to epsilon.
Cn 等于 a 平方 y 不是 a n 减，
奇怪，好像哪里怪怪的。an minus bn, this is an and is plus.
But then what's your n? We haven't fixed, haven't found your n.
Sorry,
What are your n?
is the maximum of the N1 and N2. Then for all M and N is greater or equal to N, it should be greater or equal to N1 and N2 at the same time.
So then the last.
The last will be 2.
最后第三个 term，最后第三个
错了，
B 同 B
因为他改的是稍改了一下，但是没有写，这个地方是错，但是他又不能是那个是对，确实是因为对用。He's just asking that you swap the BM and the BM is okay 了 ，it's still plus。
写完就行，
or yeah is okay。
写完就行，这个
make sense。
所以都行的 everything 是不是很烦？
用模仿。
没有要气你的意思，没有气你的意思。随便说重要。
This should be plus and this is Bm minus Bn. Then it should be An minus An plus Bn minus Bn. And this is equal to Bn minus Bn for the absolute value.
这个我可以理解。
Very good. Okay. All right.
Tí nó cùng với
Đừng bên nào. 100分了是吧
100分。
So at first, it gives us this line. So I just translate it. So I define a set Sn like this. So it means limit when n approaches to infinity, so Sn equals to L. So for the first part, it needs to show there are infinite positive integers, and so I just prove it by contradiction. Suppose finite. So it,
for some epsilon. So this one's for all.
oh,
So you need just for some. That exists. that exists at epsilon.
So it means there exists a natural number and and that's now equal to L minus epsilon. So it means for this and like because Sn is
This negation got a bit from negation. This negation is it correct or not? The for大 and for because for 大 and for all epsilon 因为它修的是 false 嘛 for 大
For all, I mean like for all epsilon become there exists epsilon.
对啊，你看 for all 变 there exist 嘛 there exist many 变成 there exist finally many 嘛
That does okay. 想一个问题啊 there does not exist infinitely many.
就是 there exist finally many 啊，
是吗？是吧？不一定的。
那所以 there it is not the case that
It is not the case that exists infinitely many.
exist finally many for all
finitely many 会不会只是其中一个情况？
我你 infinite 的反义词是 finite 吗？我
不是这个意思，我 like 它的 negation 是真的只是 finitely many。
啊，对了
There does not exist infinitely many，可能它连 exist 都不 exist。0也是 finite。
0是 finite， 1是 finite， 2是 finite， 3是 finite， 4是 finite， 5是 finite， 6是 finite 啊。There does not exist there exists infinitely many 的反义词 there exists finitely many 这挺好的。
Finitely many could be nothing of. It could be nothing also.
那finitely many 就是 exist nothing 啊。如果我没有东西的话，就是 there exists finitely many 啊。0是 finite 啊，没有错啊 ，no problem，no problem。But don't forget. Yeah, don't forget, but there's no problem.
need to write.
But then 你现在它就下面就得 exist 那个 n 了。
但那个点就是错了，为什么有 for 嘛？因为它离给吧，它离给的话那个就 for 是吧？啊，是吧？对，exist 反正就是给它写对。哎，对了，有啊，算了，给它写，给它写。对，就这个还是他说什么？
How do you go from the first line to second line？
没有，它 second line 是另外一个 condition。
哦
that exist 对对对。
Then 它也要你给那个，你也要你给这个。
后面一个是你给第一个吗？
啊，你给办不了。
不是，你给哎，这个第二行是什么东西？就是第二行 second line。What is second line that exists n in n such that？怎么忽然间建这个 second line？
就
那题目啊就
人家题目只是给那个，只是给那个
这是第一的意思。
没错。
Yeah, so 因为如果是 finite positive integers and so 必须会有大到某个 n 的时候就不满足，不然不全满足，不然不就是 infinite 必须要超过某个 n 的时候不满足了，它才是有限，才是分。
就这样。
好，
那我讲一讲。
好，
我觉得你是对的。
但是 such that 后面那个句子没有反过来。
哪个？
第二行那个 such that L 小于 L minus epsilon
转了。
上面那行没有转的，那个英语句子里面没有转。
没有，它上面是
它有 implication 就很有问题。没有它这个小图，
就是你它去 suppose 要 finite positive integer。
对，这个是
它去点击上来就把问题给分。
没有，他做的是对的，我只是他上面没有否，没有否的，
他否
为什么我否？他们在
It is not the case that exists.
对，就是 infinitely many， 对，就是 finitely many 啊。
他后面那句没有否，他 L minus epsilon 它还是 L。
我知道，问题是需要否
大于 an 小于 n，没错啊。 反而 a n 小于等于1减 f2，它反了。
没有，所以我的意思就是说，如果 z does not exist 这个东西的话，好像有很多可能性，知道吗？就是说它可能是 finally many 这个东西发生，或者说
就反正因为你就简单，
其实就是这样的，其实对，它对，它对。But it is not the case that infinitely many positive integer 会符合这个情况啊。然后他讲的就是，如果没有这个情况的话，就是意思说，它有很多东西都不符合这个东西，所以他才出了第二句话。对，
我写的不太合适。
继续。
Okay. So it means so still for this and then we can take limit for both sides.
Limit for both sides.
Yeah, take limit. So we know this is L. So this is a contradiction. So there are infinite many positive integers.
But what's the contradiction? There's no contradiction here. Because this limit
1小于等于1减 f 都不是 contradiction。
Oh, you mean anything else? Oh, because epsilon. Oh, I see. Okay, so you mean the contradiction you get is
Yeah, so they are not finite.
converge to something less than or equal to L minus epsilon. Usually we won't write like this. Usually we will write L here. Yeah, because
就没有差别了。
有差别 because this is like an English sentence. So I know that this is this, but this is less than or equal to this. It's not that this less than or equal to this first. So this is equal to this first, and then this one less than or equal to this. And then we know that what is this limit. So by transitivity, then we know this. So transitivity. Yeah. Remember, we treat this symbol as an English statement actually. 对，其实你要用句子写出来，只是我们图方便，我们把它变成 symbol。所以为了图这个方便，你要记得一下你的 order 是有关系的。
虽然一般上我会写成你这个样子，但是我并不认为他写的有问题的，这是我的意见。
写有问题是这样，最好是写的也就
我们会把这个想成英文句子，就是说我懂这个是这个线，然后在这个是这个，然后这个是这个 order 一样，华语也行，一样。
你讲把它写成英文句子，
用那我以前也是这样，那
阿巴拉的。
我确定一下咱 language
OK language OK language 还没有，还有第二段没有？还有对，还有继续。
The second part. So by the definition of limit, we know this is a definition. So by this, I define Sn as sub AK. So Sn is a non-inclusive. So Sn must be larger or equal to
Yeah, so this is larger or equal to 0. So
Wait, why Seng none?
because S is like this, so it is not included.
Oh, okay.
So so we can remove this. And since S is so okay, so for for some n larger than or equal to this a n less than or equal to S n.
Because it's lower bound, upper bound.
Yeah, this is
Yeah, so upper bound is greater or equal to n.
yeah.
You ask the people question. You ask the audience to get a question.
Questions.
哎，这个 proof second part 啊，
对对，second part 啊，proof 完了吗？
first part
啊，proof 啊，proof by contradiction。
哦，
Second part, I think the key part is how you remove the absolute value. Right? The key part is there.
不是讲了 not decreasing 吗？
我就是要 point out 这个。Yeah.
是 not decreasing not
So maybe it's worth to like say like why non-increasing your limit is like
啊，这个不是说课上讲过那句
哪一个？看看哪一个东西？
要 state 出来，
课上
要
哪一
state 出来。
个东西？
就是 S n 是负倍因数，所以
哦，这个对这个有讲，but then like 这个过后呢？过后一个 why the limit should be less than or greater or the limit is less than or equal to S n。这个应该是一个算小类吗？
所以有一点不会刚才里面是那个 infima。
So actually
讨论的就是这一题。
yeah, actually right 对吗？like 周末你 non-increasing and then 周末你的 limit 一定是在下面 yeah I think 这个的话
也不反 contradiction 吗？
我没有可以不摆 contradiction 可以不摆 contradiction 感觉我有做过这个小类吗 but then 可以不摆 contradiction
是确实有上面。非常全，是有非常高的一点。出到社会，出到生活，在有可能会变得有基本上画面样子了，你可以说。 一年小的将来就会商业突然这样继续。那你也你会感觉到这是会想或者是影响你的这样子。想到不想来这边，对这大众应该是这么大一个是是这样。
哎，I thought you want to assume SN less than M，
那我写错了。
SN less than M。
我看来发现一个是三一样，然后这也是三一是纯的。可是我觉得你啊，对对对，我是对是对的。
You think you finish? You think you finish? You want to try? Yeah, 我觉得你可以想想看。Yeah, but then if actually we did something similar for this one. If you notice the monotone convergence here, yeah, actually somewhere around there we have this kind of statement. Okay, when you have non-decreasing or non-decreasing, right, your limit must be bigger or smaller. Okay, does it make sense? I'm not sure you remember I draw some picture in class. Like, if you have like non-increasing, right? If you're gonna convert, right, you're gonna convert to something larger than it. It cannot be less than. Otherwise, you will have some epsilon here and then argue there. Okay, and then similarly, if you have I think in our case it's non-increasing. Okay, so your limit is down there. Okay, so this limit here cannot be greater than some term inside there. Otherwise, you will find some epsilon, and then after certain n, the terms will always greater or equal to epsilon. Cannot be strictly less than epsilon. Okay. Yeah. Okay. Does it make sense? I think we did something. I think as a lemma in the lecture note. You can go around monotone convergence theorem there and then try and look for it. Otherwise, maybe you can try and write it down. Then I can post it later. Try to write this proof down. Yeah. Then you send it to me. Is it okay? Yeah, and after the tutorial, send it to me. After you done. Yeah. Okay, then you can remove the absolute value and then you can just order transitivity, then you get it. Okay. Any question? Okay, so this question 7, the purpose of this question is to test you whether you know limit or not. Second is to test you know supremum or not. Okay, because if you realize that there are two parts, right? One part you are using the definition of limit. The other part you are using the definition of a supremum. Okay, so there are two part testing here. Okay, limit and supremum. Okay, these two definitions you need to know. Does that make sense? Okay, so that's why there are two parts shown here. Lim sub, so the limit of supremum. Okay, these two things. Okay, yeah, can you help erase? Thank you. Okay, any question? Your question? Have you guys read my tutorial solution? 有吗？有读吗？一点点。其他的呢？有读。有问题的话，你要问我啊，或者有错误的话，你也要跟我讲。一般错误是挺多的，你的 senior 讲，看你找不找得到。找得到有大礼包。大礼包。对啊。大礼包。再想一下。
大礼包就是多你做2天。
真的是很大的礼包。Okay, right. So in that case, we'll see you next week. Cauchy?
没有，他们又改时间2点。但是你，我